suppose you have most of must have heard about this accreditation 9000 size accreditation, and this stage you can make shoes and then you can have a 9000. So that is like a quality standards. How do you manage your quality system? So what we have in this is something gone beyond that. That is, you have the basis, of course, 9000 system. So suppose you have staff, you have to train, you have records, you have to make. But apart from that, this ISO 9000 doesn't check whether you are competent to do that. So you can make a rubbish biscuit and still have 9000. But we can't do that. We can't produce invalidated results or unreliable results from this level. So they check our competency. That's why we have accreditation, not certification. So we are ISO 17025 accredited. So that's the difference. So we got the accreditation in 2018 on for 2 cycles. And we have accreditation for electrical parameters, sourcing, and we can calibrate as instruments like multimeters. And even the voltage, mostly digital. And then the sourcing side, power supplies, and any source that has a voltage output, we can measure and give accredited certificate. And then we have pressure calibration. Electrical side, we have apart from that resistance kind of things, and it's measuring resistance or it's producing a resistance. Both ways we can do accredited calibration. Pressure gauges we can go up to the 17,000 psi. Top wrenches, this is the first laboratory in SriLankan get the accreditation for top. Maybe for SLSI, yeah, top. We are going for accreditation in 2019. One of the laboratories in Sri Lanka were accredited because top wrenches are not actually required by the authorities to be calibrated by an accredited facility. Yeah, they do top checkers, and so we actually went and bought this equipment specifically for top wrench calibration. So our laboratory was the first to get that. So we had some problems of doing some in the laboratory comparisons and all, because there are no laboratories in Sri Lanka accredited for that. We can go from 0 to 1000 millimeters. Actually, we have equipment till 1500, but in our aviation environment, the maximum we do is 1800. So we keep a limit at 1000 Newton meter. Any unit. Now this laboratory, 95% we calibrate our own. So because this was internal, which goes as a workshop, that's why we are separated. Next it's an electrical workshop. So he was the one who pioneered this place. 20 odd years ago, he was like a veteran in this area. He was the one when it was a standard room. That time it was just a standard room, and some of the playgrounds people go outside like used to work. So they shared the same space. But once we had to go for the accreditation, we could not do any of the other equipment. So we used this and only this laboratory. So we have top, and then here we have dimensions like we have calipers, dial test indicators, and micrometers. In this area, so you can see it's a special area, can control the temperature of 20 degrees. So that, and
apart from them, do you do any
no, the RF, no, we don't do. We are not accredited because the problem is that when you get your laboratory accredited for that, the first thing is a training, and then you should have other laboratories to compare your results and do some kind of test before you get there to show that your laboratory is competent to deliver these results. Now, before we get the accreditation, we used to calibrate oscilloscopes, but under accreditation, calibrating oscilloscope is very difficult. It's like this now. When you're measuring normally, there's measurement and there's an error that everyone knows. But when it comes to accreditation, we go to another parameter called the uncertainty of measurement. How uncertain we are about that measurement. It doesn't mean, it means it's a very critical number. If we just say 5, when you are measuring 5 0.1, the meteorologists, we call it, it's not a reliable measure. But we say we have 0.1 and a 0.01 plus or minus uncertainty. That gives us an idea how well we did the measurement, how is our capability. So when you are going for uncertainty is basically what we do. We use the physical side, and by experience we make an uncertainty budget. Things like while you are taking a measurement, your temperature varies. So with the temperature, suppose you are measuring a metal tape, you have a standard and you have metal, suppose you have metal plate, both will expand according to their coefficients. Can you say at this time, this particular time, what is the exact measurement and what is the? So what we do, we have a temperature variation of about 1 degree. Then we check for 1 degree how much of a expansion can occur in both these instruments, or the test piece and the measuring rule. Then we put that to the uncertainty in simple terms. So like that we see what are the other parameters. Can the humidity have effect on this? But not the human. You can't go and touch with your bare hands. You're touching, and then in that expansion you cannot take it as a uncertainty. That is a human. You are inducing it. But anything other than that which cannot be controlled. So all those small items we add it up in uncertainty budget, and then we come up with the value. Now this is the error and this is the uncertainty. So between those values, this measurement can vary. We are 95% sure about it. So when you go to such equipment, they have like standard looking how to do this budget. When it comes to RF items and oscilloscopes, they are very complicated. There are only few people who actually know how to develop such a budget. So and that number of equipment, now we have about 1 or 2, supposing oscilloscope 1 or 2. It's a ways to develop. Now you can see here we have about 50 odd multimeters. So that's a good parameter to invest. So we have to do that calibration also. So because we have the option, we have a very easy channel to logistics side. It's easy for us to get it calibrated instantly.
So it would be possible, at least in simple steps, to demonstrate, for example, a multimeter.
Now I just show you the workplace. So this is our electrical calibration, right? So this is called a multi-product calibrator. So I can calibrate many products. So basically this is a very high, precise, stable electrical source. So what we calibrate from this is an electrical measuring device. Because this is the source, so we are accredited to this. That's what we have to understand. Our accreditation is for this. That means to source a particular amount of a voltage from this to this. Now, this equipment we can go from DC 0 to 1020 volts. 1020 DC or AC. So we are accredited to source AC voltage from 0 to. So whatever, most of the multimeters starts from 1000. So I think we have the capability to calibrate most of 90% of the calibrate. So you name it, flow, any of the multimeters. Apart from voltage, it can source AC, DC current. This one actually is fully capable of calibrating oscilloscope pulse. It can look at the signals any way you want. You can like it, you can read it, but we are not using it. We are using for resistance, AC, DC current. Now we are going to go for LCR meters also if there is a requirement. Right, so this is a source. Now this is a multimeter. So we are accredited for this source. So from this, what we do, we calibrate electrical sources. Suppose we have a power supply like this. So this is our unit under calibration. So our accreditation is for this. So it's like the two sides of a coin. You can either source it or you can measure it. We have the capability for both. Some parameters, like pressure actually only measured. Pressure sensing is not a
So how often you send these for calibration?
It's like this now. sending for calibration is actually a science. You can't do it arbitrarily the way you. So normal method is if you acquire an item, the rule of thumb is every either 90 days if you have a lot of money, or 365 days you send it to an accredited laboratory. So then you do that cycle for 3 years, and then you check your results. Then you see how your each parameter, you take few parameters and then you see the deviation. If you see they are not deviating that much, you can actually extend, but providing those results. You can't just think, no, this is too costly, this is unique. Each calibration costs around $8,000, and if there normally there's a prepare. Whenever it has to go to Everett, US, yeah. It's on the other side of the United States. Takes about 3 months. So we calibrated it annually, means we are having this only for 9 months or even less, because our problem to go there and then days we take scientific data and we analyze this. This unit has a tendency to deviate this much, and we add it also to the budget. So we are the safe side. Say this is so small thing, we add it to the budget. But still, as you asked, suppose this deviate, or suppose I get it calibrated today, within 3 months this happened. Suppose my calibration frequency is 5 years, 60 months. It happened within 3 or 6 months. So from the day that I had drifted, every measurement that I do, actually maybe the error is from my reference, which is a big problem. That's why you can't actually, some laboratories tend to keep your calibration intervals to like 2 years, because actually accurate laboratory, what they have to do, if the customer proves that your reference is wrong, you have to recall all your calibration certificates and then do a free calibration, which is extremely costly. So that's why we use a intermediate check. So this is a 7.5 digit source. It can measure, it can source the 1 volt to 7 decibels, right? So obviously to measure the accuracy of this, you need a higher accuracy. So this one is 8.5. This is a Keysight multimeter. So apart from this being a reference standard, we use this reference standard to see the accuracy of this one. Suppose DC volts, right? DC volt, I keep it in the manual. I put the
zero.
no
Okay.
NPS, because you can see the digits, because this is very precise, so you can see these values are always changing. This is for the internal temperature, like that, because this instrument is very sensitive. 8.5. So it's actually measuring even the minute temperature variations as because of the thermocouple effects.
Two wire.
This is for the 2 voltage, right? Okay. So now I'll just source 0 volt, which is we call the null. Right? So it has to. You can see now maybe there is a temperature difference. Now I just took this cable, so there is a temperature gradient in this point and this one, so there is a
no,
thermocouple effect also. But you can see. Anyway, now before you take any measurements from these both instruments, there are strict guidelines how many hours you have to operate it. Now this one normally 4 hours. You have to keep it warm up. Then do your internal calibration, and then this also has its own time. And then you can't take a wire like this and then quickly connect it, because then there will be a thermocouple effect and there's a like that. So you can see now that almost is, and we just now do 1 volt, right? So it's calculating, okay, right? So now this is announced. You can see only the last 2 digits. 1, 2, 3, 4, 5, 6, 7. So what we do, we have a we normally what we do, each range we have about 3 or 4 checkpoints, like more stable points which are more critical for our environment. We know like 230 grams are okay. So we take values like this every 3 months or every 6 months. We do a check like this. But then again, we have to be very careful because this one also can drift. Right? So it is good. Sometimes we send this instrument to MUSSD, which is a National Meteorology Institute in Sri Lanka. So only they have such capability to measure something like that, because this is like a quality assurance, right? So we assure, because we are only always monitoring it with this. If this one deviates, then there's another problem. There's a problem. So to eliminate that, it's good now. Since our calibration period is like 4 or 5 years, we have to do that kind of assurance as well. So,
can you take something like that? Our error level is 0.001%, something like that.
yeah, what we do, we draw a trend analysis, trend curve, right? So we see the trend, and we keep 2 limits. The 2 limits mostly will be this instrument specification limits, because I mean, from Fluke, when they the manufacturer will give you a kind of a thick margin, because they don't want to go into the lawsuits. So they say within a year this instrument can deviate by this much. So we plot that as the limit. We can reduce it also as our requirement. But what we measure from this instrument is very low accurate gauges. You can see this is a 7.5. The maximum we can have in the aviation instrument industry is a 50,000 around a 4.5 digit multimeter. So this is, even though this one deviates, still that multimeter will not identify, because most of those values will be in the last 2-3 digits. It won't go from 1 volt, it won't generate a 1.5 volt. But still, it's not an excuse, because whenever our auditors come, they will check with this. They will check with this. They won't take your 4.5, because we are claiming our capability to have for the full range and every 8.5. So that's what we do. So we do the trends, and if we see now within now 3rd year, now these results are going to hit the limit soon, and we cut it there. So Aisha will take a decision. That's the technical manager. Whoever the technical manager in the laboratory takes a decision. It's not up to the auditors or the slab or the authority. What they do, they will come and see whether you have taken appropriate measures before.
All other laboratories here are governed by this laboratory?
No. That can you see that slide? SriLankan accreditation. They are the independent authority to. So Fluke 27 volt multimeters, you have potential meters. There is a guide. They say what are the points that you have to adjust. We go to according to that. Again, recalibrate it. We report the previous results, post results, because the customer is going to lose the original after the new multimeters they have from the software itself. If it is, since this is internal, so we don't have to actually ask permission, we just remove it. But if it is a customer office, of course we ask. We are going to remove your equipment, there may be, and then we do
You do have your third party?
yes. So most of our third party are also airlines like Fitzair,
usually
Cinnamon, or maybe there are like Emirates line. Now we have for the airport, the airlines, they keep their line stations, suppose like Emirates, Qatar, like big. They have their own, so they have a small hangar tool crib.
Yeah.
So some of their tools they may send, because, but we are very rarely we do for outsiders, because our rates are very high, and it's very difficult to bring equipment here. There are a lot of passes and all that. So who are around this place, they have already got granted. They have the authority to come to premises. They bring their tools, and we about 5%. I think we got 1,200 jobs that we do per year. Less than 5%. And obviously, I left this laboratory about 1.5 years ago.
Speaking of the staff, I'll ask the same question from him also. I asked this from his scenario. So, how many of you regularly work here?
No, we have, at the moment, we have, Aisha is a technical manager, we have another deputy also. Apart from that, we call the bench level. web studio or like that. We have two.
And if someone, one of these youngsters wants to join you in the future, so what?
Our
should
most
they
of
do?
our recruitments may go outside because meteorology is a field that we don't find it in this environment, and most of them are not very keen to join here as after seeing their aircraft and all that. Most of they are dreaming about their aircraft. But then when we have recruitments, always it will go in the top jobs also because
No, I mean, what sort of a background should they develop?
right. Okay, that question. Right. Our laboratory, the minimum qualification is NVQ5. That is a diploma. But that diploma has to be electrical or a mechanical. Obviously, because we have those two sides at the moment. But then you can join as a technician. But if you want to go to an executive grade, the minimum requirement is a degree. Because
Any degree or an
no,
engineering?
engineering degree or physical science, like science, electrical or electronic degrees are okay. Those are the related degrees. So that is for the executive grade. So we have like grade 6, 7, 5, 6, 7 is the technician grades. From above that they have executive grade and then the laboratory manager. So laboratory managers obviously.
So they don't have to go through the
School?
School.
No. Actually now this meteorology is very new to aviation. Even I told you this, we had to get this laboratory accredited because of European aviation. Because EASA, we call it EASA, European aviation. Because we have EASA also. But our authority is civil aviation authority. We release our aircraft under civil aviation. So of course all the other aircraft goes under that law. So EASA is only for the European aircraft. Suppose we handle a European aircraft like AIM device, then we have the capability to release them under EASA. So EASA only requested to have accredited laboratory. Right? If you want to have our EASA certification, then you should have accredited laboratory in-house, or you have to send all your equipment to ISO accredited laboratory. So what we did, we developed here 60-70% we calibrate here, and the rest goes outside. But civil aviation still, because most of the industries in this country